Let's talk about virtualization and processors. Basically, how one physical computer can pretend to be lots of separate machines at once. If you've ever wondered how companies run several servers or test different operating systems without buying tons of hardware, this is the magic behind it. At the heart of virtualization are special features built into modern CPUs, like Intel's VTX or AMD V. These aren't just fancy names, they actually add a new hypervisor mode to the processor. Think of the hypervisor as a manager that sits above all the guest operating systems, making sure they don't step on each other's toes. Here's how it works. The processor lets the hypervisor intercept certain sensitive instructions that, if left unchecked, could mess with the whole system. This means each virtual machine, VM, can act like it owns the hardware, but really, the hypervisor is quietly keeping everything organized and safe behind the scenes. There are a few key parts to this. First, CPU extensions. These are special instructions and modes that help the hypervisor keep track of what each VM is doing, manage their memory, and handle things like interrupts efficiently. Second, memory virtualization. Modern CPUs have hardware support, like extended page tables or EPT, that helps map out and isolate the memory spaces for each VM. So, even if two VMs are running side by side, they can't peek into each other's data. Finally, I/O virtualization. This is all about sharing devices like network cards or storage, so each VM can use them without interfering with the others. The hardware makes sure access is secure and well separated. By using these features, virtualization not only boosts security and flexibility, but also lets you get way more out of your hardware. It's why you can run a bunch of different workloads on one server, all safely walled off from each other.